Alright, good morning, calculus class today. I would like to talk about section 1.1. So, for those you need more time to go back to the lecture, so this one it's sections 1.1. So, four ways to represent a functions. So, record that domain and range. So, this one, the graphing template, this one should be listed on the should be uploaded on Google Classroom. So, you guys can just download it, save that as a PDF file. So find the domain and range for the following functions. So again, domain is just a set of all the possible x value, and then range is a set of all the possible y values. So according to the graph right here, so anytime that you want to define the domain, it's all about finding the restrictions of the x values. So you just need to look through the graph from the left to right. If you see any kind of restrictions, such as the hole, the vertical asymptotes, or any kind of like a discontinuity position here. So as you can see that, so the dotted line here on the y-axis, so this one would be considered the vertical asymptote. So what we can state for the domain, so this one you can state that it's all real number except x equals 0. But the thing is that you need to get used with the interval notation. So for the interval notations, the way to express the domain would be considered d colon, so negative infinity to 0, and then union, and then 0 to infinity with the parentheses, because at the number it's not included. Well, if the number is included, that means you want to put in bracket. And now what about the range? So quite similar. So you look through the y-axis. It's again, so you want to find out any kind of restricted value. So this one, the x-axis, which means that y cannot be 0. So the way to express the range, so it's negative infinity to 0, and then union 0 to infinity. Again, so the way to state a domain to range is always from the least to the greatest, the least to the greatest. And then for for part B, so the domain for this one, so there's no restricted value for the x-axis. So that means for the domain, it's all real number. And then for the range, it's all from -2 to +2. But -2 and +2, they're not included. Okay, so now let's take a look at that, the other example here. So the other one is finding the pattern. So given time versus temperature table, estimate the temperature 11 a.m. So one thing that you want to find out is the trend. So whether that the temperature is considered increasing or decreasing. As you can see that from noon all the way to 6 a.m. Well, actually from midnight to 6 a.m. So the temperature is actually dropping. So starting with 73 degree Fahrenheit, and then 2 a.m. 73 degree Fahrenheit, 4 a.m. 70 degree Fahrenheit, and then 6 a.m. so it's reached to 69 degree Fahrenheit. So for the pattern here, so this one is showing that it's considered decreasing. And then from 6 a.m. all the way to noon, so the temperature is actually been increasing. So this one here, so it's increasing. And you want to find out the temperature at 11 a.m. So in order to find out the temperature at 11 a.m., so that means we need to estimate the slope in between 10 a.m. and 12 p.m. Okay, so the slope here. So you just find the slope, so we do know this, that it's considered 88 minus 81, and then divided by the time difference here, then that would be 2 hours. So what we found here, it's 7 over 2, which is 3.5. Again, this one, it just shows the rate of change for the temperature, so you can state that it's a slope. And now we need to estimate the temperature at 11 a.m. So we do know that the initial temperature at 10 a.m., so it's 81 degree Fahrenheit. So according to the equation of the point slope form, so we do have y minus y1 equals m times x minus x1. So according to that 10 a.m. 81 degree Fahrenheit, so we can use that as the initial temperature. So we started out with y minus y1, so 81 degree Fahrenheit. So the slope, which is what, 3.5 or 7 over 2. And then x minus x1. So that's the difference in between the time from 11 a.m. to 10 a.m. So the difference of the time would be 1 hour. So this one, that means y equals 7 over 2 or 3.5 plus 81 degree Fahrenheit. So the temperature at 11 a.m., so it's approximately 84.5 degree Fahrenheit. Okay. So for 1.1, another thing that you need to know is about plugging a number, evaluating. So sometimes we don't just plug in a number, sometimes we need to replace a variable by the new variable. Okay, so let's start it all with the basic one. So we do have a quadratic, it's a trinomial quadratic function. So now we want to put in -2 for x. So we got 3 times the quantity of -2 squared minus -2 quantity plus 2. So using the rule of PEMDAS or GAMDAS, so basically you can just evaluate all this. So start it off with the exponent, -2 quantity squared, then that'd be 4. 4 times 3, then that'd be 12. Negative, negative, that turns out to be positive, so 12 plus 2, and then plus 2. So 12 plus 2 plus 2, then that would be considered 16. And then for negative a, so we do have 3 times negative a quantity squared minus negative a plus 2. So quite similar to the constant, the number that you put in for the previous one. So negative a quantity squared, so squared it, so you do have a squared. Because negative times negative turns out to be positive, so 3a squared. Again, negative times negative, positive a, and then plus 2. And for those you might be wondering, do I need to factor this? Well, this one it's not required, because we're not solving for any zero. We're not solving for anything, we just want to simplify the expression. And now for the next one, so we do have f of a plus h. So instead of using x here, so we want to replace that the original variable by a plus h. So that means we do have 3 times the quantity of a plus h squared minus the quantity of a plus h. Notice that once you subtract that variable, so that means you subtract the whole terms. So that means you subtract a plus h and then plus 2. And then for the rest of this, you can expand it. So this one, not quite sure what to do, you can always FOIL. So a plus h times a plus h. Or for those you would like to use the binomial expansion, so we do have a squared plus 2ah plus h squared. And then minus a minus h, because you want to distribute the -1 right here, right in front of the parentheses, and then plus 2. And now for the rest of this, so we just need to expand it, multiply it out, so we do have 3a squared plus 6ah plus 3h squared, and then minus a minus h, and then plus 2. Now it looks like there's no like term here, so since there's no like term, so that means nothing we can combine, so we just want to leave the answer like that. So 3a squared plus 6ah plus 3h squared minus a minus h plus 2. Okay, so now let's look at that, the other one here. So this time we just want to find a domain for the following function. So for the previous video, so the one that you guys watched on the Google Classroom, the one that I referred to, the one that I recorded last year, it's about finding the transformations, the structure of the function. So one thing that you need to recognize is the structure of the function. Okay, so the structure of the function, which means that it's either considered linear, quadratic, rational, exponential, radical, things like that. So this one, obviously, it's a rational function. So that means rational function, we need to set the denominator equal to 0, because we want to find the vertical asymptotes, or the restricted value, or the excluded value. Depends on which way that you'd like to refer to the name. So we set the denominator equal to 0. And now the next step, we just want to factor it. So once we factor it, we do have x plus 2, the quantity of x plus 2, times the quantity of x plus 1. And then we do have x equals -2, x equals -1. So notice the one that we've solved, this one, they're just considered a restricted value. So once we find the restricted values, so we can state the domain. So the domain for this rational function, so it's considered d colon, so -infinity to -2, union, -2 to -1, union, and then -1 to infinity. And then for the radical function, so the radical function, the parent graph, we do know that the radicand must be greater than or equal to 0. So that means for the radical term, we just need to set each one of those radicand greater than or equal to 0, so u is greater than or equal to 0, and 4 minus u is greater than or equal to 0. So solve for u for the second inequality, so we do have 4, it's greater than or equal to u. In other words, u it's less than or equals 4. So once you set up the domain, so the domain for this one is considered 0. Okay, so this one I put it u it's less than or equal to 4. So from 0 to 4. And they're both considered bracket because that it comes along with the equal sign here. So that means the numbers, they also consider part of the domain. Okay, so now let's see what else that we have for the rest of this. Another one, this one is a composition. So this one to deal with the whole picture. It's considered rational. But part of the function here, so the denominator, it's considered radical. It's an even radical. So one thing that we notice, if that's an even radical, so the parent graph is always considered like this. So that means the quantity, the radicand, that means the element inside the radical, must be greater than or equal to 0. So that means we need to set that x squared minus 5x is greater than or equal to 0. Now the thing is that this one is considered non-linear inequality. In order to solve for the non-linear inequality, so first thing that you want to do, you want to factor it. So we got x times the quantity of x minus 5 is greater than 0. And now from here, you want to find out the 0. So we do have x equals 0, x equals 5. Another thing that you want to do, you want to set up the line test. So normally, if the domain, there's no restricted value, it's always from negative infinity to infinity. But since we find out that the 0 here, so we got zeros, and then 5. As you can see that we do have 1, 2, 3 different interval here. So we need to test the interval by plugging the number. So number that is less than 0, but it's greater than negative infinity, so we can plug in negative 1. So by the time that you plug in that number, make sure that you put it into the factor form. So the factor, we do have x minus 5, and then the result. So negative, x equals negative 1, so it's negative. So x equals negative 1, so negative 1 minus 5, which is negative 6, is still considered negative. But negative times negative is positive. So in order to satisfy that the inequality, so we need to have something that's greater than 0, greater than or equal to 0. So this one is positive, which means it's greater than 0. So that's part of the domain. Yes. And then the other one from 0 to 5. So let's plug in something that's right between 0 and 5. So let's put in 1. So we got positive. 1 minus 5, so it's negative. So positive times negative, which is negative. So negative, which is less than 0. So it's not part of the domain. And then the next one, we put in something that's greater than 5. So let's say 6. So 6, positive. So positive. 6 minus 5 is also positive. So positive times positive, which is positive. So that's also part of the domain. And as you can see that the yeses column, so what we have is from negative infinity all the way to 0. Again, 0 is included because that with the equal sign. And then union, 5 is also included because that it's greater than or equal to 0. So 5 all the way to infinity. And that it's a domain. So again, anytime that you deal with the composition function, you got to be careful with the inner functions. So for the inner function here, so it's a radical, it's an even radical. So we need to come up with the restricted value. So once we come up with the restricted value, but don't forget, it's a nonlinear inequality. So that's why we need to do the line test. So for the next type of problem, we want to put in the transformation with the graph. So the one that we did last week, it's about the all the functions like linear, quadratic, rational, exponential. So we actually talked about that already. But this one, before you come up with the transformational form, so the one that we have a times the quantity of x minus h, quantity squared plus k. So what you need to do first, so you want to complete the square for this. So the way to complete the square for this, so we just want to put it this way. So y equals x squared minus 6x plus blank. and then minus the blank. So what it's saying that whatever the number that you find out to add here, you want to subtract the same number. Well, the reason why that we have to do it that way is because that we need to balance the equation. So in order to figure out the number, the way to figure out the number is b over 2 quantity squared. So for the value b here, so it's negative 6 divided by 2 quantity squared. So we do have 9. So that means we need to add 9 here. And then at the same time, we need to subtract 9. Again, we need to balance out the equation. So y equals, so now for this trinomial, so we can factor it. Again, the purpose of doing the factoring, the purpose of completing the square, so that means we want to factor it. So we want to come up with the perfect square form. So eventually this one is written as x minus 3 quantity squared, and then minus 9. And as you can see that a, it's considered 1, and then h, it's 3, and then k, it's negative 9. So again, h comma k, so that would be considered the vertex. So once you sketch the parabola, so start with the vertex. So it's 3 to the right, and then 9 unit down. So 3 unit to the right, and then 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way down here. Another thing that we can do, we can set up the y-intercept. The way to find the y-intercept, we can just put in 0 for x. So 0 minus 3, then that would be considered negative 3. Negative 3 quantity squared, that's 9. 9 minus 9, then that would be 0. So 0, 0, that's the y-intercept. And for those you might be wondering, how do I get the third point? Do I need to put in another x value? Well, I mean, that's one of the options. Another way you can do it, you can always use the line of symmetry. Again, the vertex, it's not just showing the vertex. The x value, it shows the line of symmetry here. So it looks like this one, it's 3 units away. So that means on the other side, it's also considered 3 units away of the line symmetry. So that means the third point would be over here. So that would be 6, 0. And then once you get those dots, all you need to do is just connect them. And that would be the parabola. And what about for the absolute value of 3x minus 3? So now this one, so let me open up the news page right here so I can show you the word. So for f of x, so we do have absolute value of 3x minus 3. So basically what you can do, you can just take out that 3. It's the greatest common factor, so we do have absolute value of 3. And then times absolute value of x minus 3. So this one is written as 3 times absolute value of x minus 3. And compare that to the transformational form. So y equals a times absolute value of x minus h plus k. So h comma k, which is the vertex. So for this case, so h is 3. And then k, if that's not shown, that means it's 0. So there's no vertical translation. And then 3 here, so that's just the value of a. Now let me tell you what a stands for the absolute value function. So a, so this one is considered the slope. It's considered, well, I try to do the absolute value, it could be plus minus 3 over 1. Okay, so that means for the graph, it's going to be like this. So started with the vertex, so 3, 0. And then for the slope, it's up 3, 1 over to the right. Okay, so up 3, 1 over to the right. Or this one could be considered up 3 and 1 over to the left. Because again, the slope could be either positive or negative. Okay, so once you get those dots, simply just connect them. And that'll be the absolute value graph. Okay, so going back to that slide here, so let's see what else that we have. So the piecewise function, so this one is given as f of x, x plus 9, the linear. So x is less than negative 3. So the other one, f of x, negative 2x plus 0, if absolute value of x is less than or equal to 3. So for this one, if the domain is given with absolute value, you can always break it apart. So that means x could be either less than or equal to 3, or x is greater than or equal to negative 3. And then the third part, it's considered negative 6 for any value x is greater than 3. So the graph is already sketched. So what you need to do, so you started off with the center part of the piecewise function. So what I did, I started with the second part of the function. So this one is linear, so that means started at 0. This one's supposed to be intersecting at 0. And then the slope is negative 2. So negative 2, that means it's up to 1 over to the left, or it could be down 2, 1 over to the right. Okay. So as you can see that, so this one, you can just put in the graph from negative 3 all the way to 3 for the domain. And then the first part of the piecewise function, we do have x plus 9. But the thing is that x plus 9, we don't start it with the y-intercept here. It looks like what I did here, I started with the y-intercept. But actually what I did, I actually cut off this part of the graph. Well, because that the domain, it's only for x is less than 3. So anything that x is less than 3, so we do have a graph of x plus 9. Okay? So basically you can start it off right here, but by the time that you finish that off, so you need to erase the one that is outside the domain. Okay? So anything that it's considered greater than or equal to negative 3, it's not part of the linear function here. And then the other one is quite similar. So anything that is greater than 3, so that means we do have what? Negative 6. So again, you can start it off right here at 0, but the thing is that this one from 0 to 3, it's not part of the domain. So the domain for this one is for anything x is greater than 3. So y equals negative 6 for x is greater than 3. So we do have a kind of like a triangles and then the line graph. Okay. So now, let's see. Okay, so now the rest of this is about the odd even functions. So recall, odd function is considered things that we have. It's considered f of negative x is the same as negative f of x. Okay. So anytime if this one is true, so that means the function is considered odd. Even function is showing that f of negative x is the same as the original one, f of x. So if this one is true, that means the function is always considered even. So now for the rest of the example here, let's determine whether f is even, odd, or neither. Another way that I can find out odd or even function is about looking at the power. So the power here on the top, it's 2, so that means even. Power down here is 4, and then 1, so that means the power is considered 0. So 2, 0, 4, those are even number. So that means the function eventually is going to be considered even. But if you just want to stay that way, that's kind of like a shortcut. But a better way to explain it is by using the tests. So in order to find out that's even, so we need to satisfy f of negative x equals f of x. So f of x is given already. So what we need to do, we just need to verify that f of negative x. So negative x, quantity square, over negative x, quantity to the power of 4, and then plus 1. And you may notice that negative x quantity squared, it's the same as x squared. And then negative x to the power of 4, it's also the same thing, x to the power of 4. And then plus 1, so basically this one is the same as the original function. So therefore, f of x, it's even. And now what about for the absolute value? So for the absolute value, looks like this one eventually it's going to be considered odd, because this one is x to the first power, absolute value, x to the first power. But the thing is that, again, we need to verify it. So let's start it off with f of negative x. So for f of negative x, we do have negative x times absolute value of negative x. So absolute value of negative x, so absolute value, that means it makes everything positive. So positive times negative, so eventually it's going to be negative x times absolute value of x. And then for the negative f of x. So this one, we want to take out the negative sign. So putting negative outside the whole function, so we do have negative, or negative 1 times x times absolute value of x. So this one distributes, so eventually it's going to be negative x absolute value of x. So as you can see that this one, f of negative x, is the same as negative f of x. So this one you can say that it's odd. It's an odd function here. Okay, so now, and pretty much that's about it for sections 1.1. So any questions and concern, make sure that you come by to the office hour or the after school tutoring, the one that I have for another Zoom link. So any concern or things that if I'm going too fast here, you can always rewind or fast forward and then just catch up with the one that you struggle. Alright, so I'll see you guys next time. Take care.